About B and C together today. Um, we are trying to solve differential equations, but not the ones we talk about in exercise A, the very complex ones. So we may only have one like derivatives in the equation. It can either be first derivative or second derivative. And the whole equation can either in terms of x, the whole thing in terms of x, or the whole thing in terms of y. Okay, so basically, for example, the first one, we have dy dx. That's a differential equation. We have the equal sign. We have the derivative. And we have that in terms of x. Okay, or we have second derivative. Okay, or we have second derivative. We have like that's the second like order derivative functions, and we have the whole thing in terms of x as well. Or we have like dy dx, that's a differential equation, first order differential equation, but that's everything in terms of y. The right hand side is in terms of y. And that's a first order differential equation as well, and in terms of y. Okay, that's in terms of y. Um, just give you a general idea on it. So dy dx, that's the first order derivative and differential equation, and we have everything in terms of x. Okay, now the key idea here is either in terms of x or in terms of y. And then you either have dy dx or d squared y and dx squared. And we're trying to solve. How do we solve? We're just basically doing antiderivatives. Okay, so back to chapter 7 again. Everything, we just want to do antiderivatives for everything. Okay, I'll just pick like a couple of like typical ones with you to do it together. Um, okay, for the first one, that's pretty easy if I want to find out y value. So we have y equals to the integral of 1 minus e to the power 4 minus 2x, 3 over square root 1 minus outright root 5 here. So we can see that's a sine inverse. Okay, you can see that's a sine inverse. So what I will write is root 5x here and squared. And well, we will have root 5 on top because it's the g dash x. So therefore the coefficient I'll write as 3 over root 5 of dx. Okay, it's exactly the same as what we should have, but you just make it in the better form, like there's a plus sign. And then we have y equals to negative a half e to the power of 1 minus 2x and plus 3 on root 5 sine inverse of root 5x. And don't forget to plus c at the back because your actual solution can be anything with any constant. Okay, can be with any constant. So the two chapters, this two exercises is basically just doing antiderivatives. Just solve for y. Andy, what do you need? Okay. Okay, that's the first one. And if we have second derivative, okay, just do one example with second derivative. If we have second derivative, what we can do? Okay, so first of all, the second derivative, if you antiderive that once, you will have the first derivative. Okay, if you antiderive that once, you have the first derivative. And what method we should use to antiderive this one? Substitution. So we sub u equals to x squared plus 1 and du dx should be 2x. Then dx equals to du over 2x. Then that equals to, well, if I cancel, you can see if I cancel that, the top should be a 2, and you should have a u squared of du. Okay, directly sub this into that spot. And top and bottom canceled, 4x and 2x got the 2 left. And then du, we change the bottom, becomes u to the power of 2. Then that's 2u to the power of minus 2. And that's minus 2u to the power of minus 1. But remember, you need to plus c here. Okay, even though that's the first derivative, you still need to plus the c value, okay, for this one. Then, okay, that's the dy dx. So we just need to solve that again. Okay, we just need to solve that again. That's minus 2 over u plus c. Okay, that's the important part. You will have a plus c, like that's a variable here. Okay, that's a variable here. You need to plus the c value. Because antidiff a constant, you will have like cx. Okay, you have cx. So therefore we have y equals to minus 2. Oh, sorry, what's your u? I haven't substituted that back. No, I haven't substituted that back. Sorry, I can't do that. So what's your u value here? You can't because you will dx in the end. You can't keep it. You will dx. Okay, that's not correct. I haven't substituted my u back. So that should be a minus 2 over u plus c. And that should be, what's that? Minus 2 over x squared plus 1 plus c. So I can't do it by that way. If you du in the end, yes, you can do, like, you can keep the u, but I'm not going to do du. You have the dx here, so you need to antidiff like regards to x, not to u. So you need to substitute things back at this step, and then antidiff this function to make it. So we have integral y equals the integral of minus 2 over x squared 1 plus x squared plus c of dx. So I must substitute that back. I can't just keep it as u. I won't have a log. You can see that. I won't have a log. So what's the antiderivative of that will be? Tan inverse. So 1 plus gx squared and g dash x, so it's minus 2 tan inverse of x plus cx plus d. Okay, so you have two variables in your equation, and c and d basically can be any value, unless they give you 2 points on the curve and you can solve for c and d values. Otherwise, it can be a general solution. C and d can take any value here. Okay, that two example is showing you give you first derivative or second derivative in terms of x only. Okay, in terms of x only. Let's have a look. If you have dy dx in terms of y, what you could do. This is really important when we lead through the next exercise. So what we can do, how we can solve that. Yes, correct. Thank you. So we need to have the bottom one have the same variable on your right hand side. Otherwise, you can't just antidiff both sides. So if we flip it, that becomes 1 over cosine squared to y. We have that. And dx dy is basically the sec squared of 2y. What x equals to in this question? Like, is antidiff, well, if you have dx dy, x equals to sec squared of dy, antidiff of that, yeah? So it's 10 half 10 to y plus c again. Okay, it needs to plus c again here. But we need to make y to be the subject. Most of the question will ask you to make y to be the subject. I'll just talk a little bit about the, what is it called, the application. We have, like, say for example, population and time. You should make population to be the, like, to make p to be the subject and t is the dependent variable, because t is changing and that's why p is changing. So you need to have p in terms of t. So same reason here, like x change, like that's the dependent independent variable, and then y is changing like when x is changed, so y needs to be the subject, because always use sketch graph is y on top and x here, x on the horizontal. So we need to rearrange the equation. Okay, it's not necessary, but because if I want to talk about the application for next lesson, it will be easy to talk through this now. If I move everything to this side, what I will have is like that. Okay, so if I move everything, I will have that. I want to expand my left hand side. But my left hand side, if I expand it, that here, and that's 2x minus 2c. I don't c is just a general like constant at times by 2. I can just easily change that to d. It will be easier we do if you know how to do this for application question. I will show you. It's like really magic. You just keep changing the variables, and in the end you like simplify your answer to a really simple answer. So if you keep using a lot of variable times together, the answer get really complex and hard to solve. We just change 2c to d. Like there's nothing wrong with it. Like 2c is another constant. I change to d. That's like minus 2c, just equivalent to d. Nothing wrong with it. It's just a constant. Okay, so it depends on what's the c value, and that depends what's your d value. So what we will have is 2y equals to tan inverse of 2x plus d. You can write 2x minus 2c here. Nothing wrong. I just feel it's easy to use. And you'll see tomorrow why I said it's easy to change this to another variable. It's basically for me to solve this, and I just want to make it easier to solve this. Okay, so what we have is this one. So y equals to half tan inverse 2x plus d. You could write 2x minus 2c. But think about when you sub a point in. You just solve out different c and d values. Your final answer will be exactly the same. Okay, so there's no difference. Any questions about this? Like it's just how this step jumps to that step and how that step jumps to that step. That's pretty important. Okay, and just do one more example with you, and then to show you like a use of calculators, and you can do the later exercise by yourself. It's pretty much just using chapter 7 knowledge, how to additive things. Okay, what's the first step we should do for this one? Flip it. So dx over dy equals to 1 over y squared minus 3y, and x will equal to the antiderivative of y squared minus 3y of dy. What I should do here? Partial fractions. Again, how do you see that should be a partial fraction question? You can factorize the denominator, so that's a hint for you, like you can do partial fractions. Okay, so when you see the denominator, I can easily factorize it to make y times y minus 3. That's a hint for you to think about. That might be partial fraction, or most likely to be partial fraction. So that's just integral of a over y plus b over y minus 3 of dy. Okay, so y times y minus 3. And I will just write it here. So a times y minus 3 plus b times y should equals to 1. Okay, cross multiply and add them. You should have the original numerator. Well, I see a lot of you like to do expansion. I mark your test from the previous chapter test. A lot of you just like to expand it. Trying to think about just substitute values, that will be a lot easier. If you sub y equals to 0 in this case, you just have minus 3a equals to 1, and a equals to negative a third. And you just need to pick like smart values. If you sub y equals to 3, the a coefficient get to 0, and just get to 3b equals to 1, and b equals to a third. Okay, it will be much easier if you do substitution. If you expand it, you need to solve them simultaneously. I think it's hard. Okay, if you do, well, it depends on you. As long as you can get the right answer, I don't really mind. I just think this method is really good. Okay, so we have x equals to integral of what a is minus, I'll write b first. So it's a third times 1 over y minus 3 minus a third of 1 over y. Okay, I don't like to write fraction over fractions, so I will write them in that way. So a is minus a third, so I put it next, and b is positive a third, I put it in front. So it's a third times 1 over y minus 3 minus a third times 1 over y. So x equals to a third That's a log, right? Log e y minus 3. After you do partial fraction, most of the questions will be log. Okay, most of like it's always like a linear at the bottom, so it's most likely to be a log. And a third of log e y here. And plus c. I need the modulus, sorry. I need the modulus. Okay. I need the modulus here. And okay, plus c. What you can do with this plus c? Like, I can move it across to the other side and times by 3, right? So yeah, so it's 3 log of x minus c. And then on this side is log e of modulus y minus 3 over y, like that. Okay, I'll show you like a really interesting thing. So what I have is y minus 3 over y equals to e to the power 3x. As I said, you can make a plus c here, right? Correct? Agree? That's the magic part. Okay, let's talk about the modular sign. What you can say about the modular sign? Like it always needs to be positive, right? Like this side is always positive, like which makes sense. Otherwise, the modulus, if you have a negative number on the side, which is not correct. So which means like the left hand side, right hand side should be all positive, and e is always positive. So what is interesting here is e to the power of 3x plus b. I can write as that. Do you agree? Like a times in between. Power adding together. What's e to the power of b? It's a constant, right? That's just a constant. Okay, you will need to use this tomorrow. Can you see how easy this like it will be still the same if you write this answer. Nothing wrong with it. It's completely fine. It's just make your calculation a bit harder when you do substitutions. And also, normally when you sub x equals to 0, and then the whole thing becomes 1, and a is just the initial value, right? So a is normally the initial value. So that's why it makes the calculation a lot easier. Okay, so that's the step. Jump to that step. And also, this a could be positive or could be negative, right? When you get rid of the modulus, it's basically just plus minus of this number, right? But a can be just positive or negative. It doesn't really matter. It depends on how you solve it. When you start the value in, it depends whether a is negative or positive. So I don't really need this plus minus here. Okay, I don't really need this plus minus here because a could be positive or a could be negative. No, no, no. This a, but yes, correct. But how I can say this thing can be negative because you put in modulus. For example, the right hand side is always like say 4, but inside could be plus 4 or minus 4. The left hand side can get negative. So which means the inside, like whatever here, it could be negative 4. Like yeah, do you understand? Like no, when you start the value in, you only have unit constant. You need to pick plus or minus when you start things in. Like it depends on what that value you have, and you pick a value. It's not like two different answers. It can be in here. Yes, it's two answers because in general you have plus or minus. But when you have a point to sub in, you only pick one side. So only pick positive side or negative side. Because a can be positive or negative. Like say a could be 2, a could be negative 2. You can leave it there. It doesn't really matter. You can leave it there. Like it won't change the answer. But again, so what I mean here, again, right? This is I think when we do kinematics will make more sense to you because in this case I haven't give you any value to substitute in. You haven't sub anything in, so it could be plus or could be minus. But later on, say when I give a point, say a comma b, ask you to sub that thing into the equation, you will only pick the positive side or the negative side. would say I'm not going to like push this too much. You just leave the plus minus here. It doesn't really matter. Okay, just keep the plus minus here. I don't really mind. And how we can solve this? How we can solve for y? Let's assume we have the plus minus here. How we can solve for the y value here? How we make y to be the subject? Okay, so what we have on left hand side? Y minus 3 of y equals to plus minus a times e to the power of 3x. And 3 of y should equals to 1 plus minus a over e to the power of 3x, right? And y should be 3 over 1 plus minus a e to the power of 3x. In this case, you won't get the mark down. Like after here, you won't. Yeah. But when you have a value to substitute in, you need to make your decision in that case. But we don't have that case yet. When we talk kinematics, it should make more sense to you. I'll show you a couple of questions why we only pick one. Okay, don't worry about that too much. As long as you have this also or have the plus, it will be fine. All right. What I care more is this, all of this part. Okay, how we can simplify exponentials. Like when we get a variable c, how that change to d and how that change to a. Okay, so on like exponential. So tomorrow we'll continue to talk about that with some application questions. But like today, I just want to talk about how to solve differential equations. All right, if you have your calculator out, I'll just show you the examples for the next example. All right, I'll do A and I will do C with you by using CAS. Okay. So okay, we have something called differential equation solver. Okay, differential equation solver, and I want you to write this down. What's happening? Okay. Okay, so where is it? It's in menu calculus, and the differential equation solver. Okay, what's differential equation solver? Basically, it's help you to solve first order derivative functions. Okay, first order derivative function. I haven't figured out that function yet. I think there will be another function to be able to solve it. I will figure that out and let you know. Okay, solve. Okay, so what I'll type, you need to type very specific things. You need to type y dash. So you type y, and where's the dash? The dash is in pi. Okay, so it's here, this dash. Okay, in pi. That is the same as dy dx, but I don't think you can use dy dx here. You just need to type y dash in and put y dash and put your dy dx equals to what? Okay, the good thing about this is it doesn't matter it's in terms of x or in terms of y. If you have in terms of y, time in terms of y. If you have in terms of x, times in terms of x. It can be in terms of like x or y or a mix of x and y. So what is your dy dx? Just directly type that in this dsolve thing. So we have x minus 1 x squared. So we are doing exercise A, 6a. So plus 4x plus 3. Okay, so that's the differential equation. What's another good thing is I can sub points in that. So you know you will have a plus c in the end, and then we need to solve like the c value and then get it back into the equation. What I'll type is a space. A space, like space at the bottom right corner, and type and, A and D. Just type and another space. So it's space and space. Okay, space and space. And we can put the initial value in. So the initial value is y0 equals to log e9. Okay, type y bracket 0 equals to log E9. I don't think so. I think that's a specific instruction for this calculator. You cannot type this in. For example, if you don't have a point, you can just don't type this. But if you want to add a point in, you need to type here. You know the given is only given x value or given y value. It's not given both x and y values. So here is just showing you both x and y's. There might be other ways of doing it. I haven't figured that out. So you can try. If that works, you can let me know. And I can teach the class. Okay, after you put the initial condition, if you don't have the initial condition, you don't need to type the and space and thing, you just delete all of that. But we put comma x. Okay, what's comma x? You might have dp dt or dt dp. So it depends on what is your independent variable and what's your dependent variable. So you put comma x, which is the independent variable first, and then comma y, which is the dependent variable. So for the PT case, I will comma T, comma P. T is the independent variable and P is the dependent variable. So independent first and then the dependent, or say horizontal axis first and then the vertical axis. So comma X, comma Y. And the magic will happen, so it will show you the answer directly. Any questions? I'll show you what will happen if you don't have the initial condition. So if you don't have the initial condition, just type whatever and then don't have the space, just comma x, comma y. You will have something in general, and C3 is the C value, and you just need to substitute or keep the C there, like in your answer. So in this case, it's just solve the C for you already, so you have the C. I'll do another one with you, okay? Write that instruction somewhere, okay? You might forget, because my students also forget calculating instruction and they keep asking me later. We'll do this one. So y dash equals to square root 4 minus y squared. Okay, y dash is exercise C. So what I'll do is menu for D, so differential equation solver, menu for D, so differential equation solver. So y dash is in pi, okay, again, equals to, I'm not going to flip it, okay, when we put into a calculator. What you have, just directly type in. Doesn't matter it's in terms of x or in terms of y or mix of x and y, doesn't matter. Just type that in. And we have space and space. Y power 3 equals to 1. Okay, in reading form, check your calculator is in reading form. So pi on 3 equals to 1, comma x, comma y. Okay, two variables. Okay, can you see in my differential equation, I don't have x at all. But I'm telling the calculator my independent variable is x and then the dependent variable is y. So you have things in terms of x and y. But we have like, it's not y in terms of x or x in terms of y. We just have a function. What we can do, I'll try if I can get that by that way. You can, I think for circular functions, you just rearrange that by yourself, just by hand. I will try to figure, I think there should be a function for second derivative. I'll try to figure that out, like see if there's another. Directly by dissolve, y dash dash. But how to sub two conditions in? Can you? I tried once and I failed. I'm not sure. Let's try that. Comma x, comma y. I tried that. I tried to enter the condition twice into the calculator, but I failed once. I'm not sure if I got the instruction wrong. Let's try that now. So if I think you should go for dissolve like twice. Do you have a second derivative question? Do you have a second? Well, we just use, yeah, the first one. Let's just use the first one. 4x over x squared plus 1. 0, 0, let's think. We have 0, 0 and pi on 4, 1 pi or something. Okay, so y dash dash equals to 4x of x squared plus 1 squared. And okay, I want to put two conditions. For example, it's and y0 equals to 0. That's my first one. And space y1 equals to pi. Let's make it pi. Comma x, comma y. Oh, that works. Okay, good. Works. Okay, just and twice. I think last time I didn't put another and. I just put one condition and another condition. Space and space, condition and space, and another and. So I just change, like I just sub. There is a space. I type another space here. I think it just disappeared directly. Same answer. You need it. I think you better type it in. It disappeared directly by itself after doing the calculation. So let's try. That's the instruction I learned. I should put a space there, but if I, well, still works. I will see. But this one, the space still have it. They still have the space here. Just put it in. It doesn't hurt. Okay, so second derivative, you just put two conditions in and comma x, comma y, just y dash dash. Okay, any other questions for the calculator? Okay, if no, you can try to complete the rest. You can do that by hand and solve that by hand, and you can check your answers. Okay. Tomorrow we're not going to learn the exercise in that order. We are going to do D, so which is the application question. Like because we have the double there, it's good to fit that lesson into the double. So we'll do, which page is that? We'll do page 15. Okay, we'll do page 15 tomorrow. We'll do 15, 16, 17. It's quite a lot of application questions tomorrow. Yeah, tomorrow. So we start from page 15.